So our home plate for tonight, it says represent the following 4 different ways. Number 1 is 2 and negative 3, or plus negative 3. Number 2 is negative 5 plus 9. Number 3 is negative 1 plus 4. Number 4 is 7 plus negative 5. Number 5 is 2 minus negative 3. Number 6 is 5 minus 9. Number 7 is negative 1 minus 4. And number 8 is negative 2 plus negative 5. Copy that, please. So that's the home plate for tonight. So let's get started. Get your Cornell note in front of you. And our objective for today is I can add and subtract real numbers. Stay with me because it's going to go a little bit faster, so just bear with me. I can add and subtract real numbers. Read together. 1, 2, 3. I can add and subtract real numbers. All right, so that goes on the bottom left. Copy that. And once again, at the end of the day, I'm going to upload the video so you can have it accessible. Okay? So, what is the concept for today? Tell your neighbor, please. What is the concept for today? Very good. Real numbers. Yeah, and if you notice, it's in green. Therefore, the concept and the objective is in green. All right? All right, here we go. So, real numbers. What are they? The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. Bless you. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. Tell your neighbor the definition, please. All right, so what kind of numbers can be represented on the real number line, such as 2/3? Yep. 7.25? Yep. 23, Michael Jordan? Yep. Negative 8? Yes, that can also be represented on the real number line. Pi? Yes. Square root of 2? Yes. All those can be represented on the real number line. And yesterday we had introduced another concept. The concept was integers. You guys remember that? So I draw the number line down here. Check this out. Do the same. And the number line for integers included counting numbers. You guys remember the counting numbers? 1, 2, 3, and all those. But counting numbers plus the 0 become whole numbers. Remember that? But integers are whole numbers including what? They're opposites. So negative 1, negative 2, negative 3, dot, dot, dot. So these are integers. But all these numbers together on this number line, they're called real numbers. Bless you. Why? Because it can be represented here. So let's see. Can 2/3 fit here in between 0 and 1? Yes. How about 7.25? Over here? Yes. How about 23? Yes. Negative 8? Yes. Pi, 3.14 approximately, and square root of 2. Are we there? Now, writing utensils down and pay attention. Look up to the screen. I'm going to give you one more that is a real number. Square root of 16. Now check this out. A common mistake that people do with square roots is that when you see the square root, your noodle, some of you, think of dividing by 2. I don't know why. That's a common mistake. But from now on, I want you to think of square roots as, look up to the screen, a number times itself to give us this number. A number times itself to give us that number. Therefore, square root of 16 is what number times itself? What number times itself? Julian? 4. That means, is this a real number? Yeah, square root of 16 is right here. Is that correct? Okay. However, there is another number times itself that gives me 16. Think about it. A number times itself that the product is 16. What do you guys think? Yes. Negative 4. That is correct. Negative 4 times negative 4 is positive 16. You everybody understand that? Okay. So far we got this, right? Now let me give you a non-example of real numbers. Give me a second. Copy this one. Square root of negative 16. Square root of negative 16. So, square roots, we know it's not dividing by 2. Is that correct? What is the rule? A number times itself. Okay, so let's see. One number times itself give us negative 16. Julia?
Nothing, because the negative times the negative will equal positive. And you can't use negative times the positive because then it won't be truly itself multiplied by itself. But it could possibly work for a cubed
right.
root.
Did everybody hear that? That negative times a negative cannot work because it becomes a positive. Positive times a positive doesn't work because it's still a positive. And we can't use different signs because what is the rule? A number times itself. Therefore, check this out. If all these are real numbers, this one has a specific name. Look up over here. Tell your neighbor what it's called. The correct term is imaginary. That is correct. Write that in there. Imaginary numbers. And these do exist, by the way. These, once we get to Algebra 2, you're going to be using these numbers, also known as complex numbers. Imaginary or complex. Yes, sir.
Okay, so there's also another number, quote unquote, that I want to put as a non-example. Omega. To get to omega, you have to get to the end of infinity. So you skip the end of infinity, and then you get to omega.
Thank you. All right, here we go. So what would go here in the critical attributes? Basically all numbers on the real number line. But keywords here are real number line. Everybody with me? So write that in there in the critical attributes. Underneath that, I want you to write some steps. So underneath your prayer model, write steps. Here we go. It's only 4 steps. Copy this. To add and subtract real numbers, I add the opposite of the second number to the first. Number 2, represent each number on the number line with tile, symbols, and ground zero. Number 3, identify all zero pairs and use absolute values to add. And number 4, simplify. Copy that, please. So as you're finishing up, check this out. Today we're going to be representing expressions 4 different ways. Now, we started with, this school year, algebra tiles, didn't we? We know how to use those, okay. In the past, you've used the number line, right? I'm going to refresh in your memory with number lines, okay. Do we know how to use ground zero, right? We introduced ground zero. Using symbols, I'm basically going to use the rule using absolute values, and that's more like a review from last year. I'm going to show you that in a little bit, okay. So those are the 4 different ways that we're going to represent expressions. But before I get there, like I said, I want to review absolute value to make sure that it refreshes your noodle. Okay? Is everybody done? Okay, here it goes. So, look up, writing utensils down. Check this out. How to use absolute values to add numbers. So here we go. I'm going to add these 2 pairs of numbers that are the same sign using absolute values. Look up to the screen. I'm going to start with these 2. Absolute value of 3 is 3. Absolute value of 6 is 6. Oh, I'm sorry. There you go. Absolute value of 3 is 3. Absolute value of 6 is 6. Now, since they have the same symbol, starting with, we're going to add these 2. So what is 6 plus 3? 9. What is the symbol for both of these? positive. That's why this stays a positive 9. Are we there so far? Okay? Absolute value of negative 2 is 2. Absolute value of negative 9 is 9. Since they have the same symbol starting with here, we add these. 9 plus 2 is 11. But what is the symbol for both when they started? Negative. That's why it's negative 11. Is it coming back somewhat? So look at these. Now these are two numbers with different symbols. Let's see. Absolute value of negative 8 is 8. As absolute value of 12 is 12. Since they have different symbols, I'm going to subtract these. What is 12 minus 8? 4. And then I look at the greatest absolute value. The greatest one is 12. What was the original symbol of the 12? Positive. That's why this one stays a positive. Absolute value of 3 is 3. Absolute value of negative 15 is 15. And then since they're not the same symbol, we subtract 15 minus 3, that's 12. Which is the greatest absolute value? 15. What was the original symbol? Negative. That's how we get negative 12. Are we there? All right. And of course, to recap, 0 pairs. Remember these? Ground 0. That's also what we're going to use. So copy this. Example 1. It says add 4 ways, negative 3 plus 7. If it doesn't fit on the front side of your Cornell notes, do this in the back because you're going to need plenty of space. It says add 4 ways, negative 3 plus 7. Once you copy that, I want you to do this. We're going to create 4 partitions like this. So the first way is what we started with. It's using tiles. So what is the first number? Negative 3. So we write 1, 2, and 3. What is the second number? Positive 7. So we write 1, 2, 3, 4, 5, 6, 7. Circle your 0 pair. And what do we have left? Positive 4. The second way is how we started the school year after we watched our video for the additive inverse property. Ground 0. Here's your ground 0. What is the first number? Negative 3. So we dig a hole of negative 3. From there it's positive 7. That means we have how much dirt up here? Very good. 7. So question. Will this whole dirt fit in here? No, only part of it, right? So I'm going to guesstimate that it's about right there. So this, it's going to fill this whole thing. So what's left over here? Positive 4. The third way, I said we're going to revisit number lines. Here we go. For those of you that still didn't get a mastery of this last year, today we will. Here we go. Started with 0. Anytime we're representing addition with the number line, we always start from 0. Here we go. What is the first number? Negative 3. That tells us that we're going to go from 0 to the left. How many steps? 3. So I'm going to go 1, 2, 3. And I'm using red if you have your pen. So this is negative 3. The second digit tells me that I need to go to the right 7 steps. But I'm going to go to the right from where I'm at now. I don't start again from 0. So where am I at right now? Negative 3. So that I'm going to go 7 to the right. I'm going to go 1, 2, 3, 4, 5, 6, 7. And that should land me in positive 4. Okay? From there, the last one, we're going to use the absolute value. We got negative 3 plus 7. So let's start with absolute value of negative 3 is 3. Absolute value of 7 is 7. Are the original the same sign? No, so we subtract, so it's 4, which is the greatest absolute value. And the original symbol of 7 is positive, so this stays positive. And those are the 4 ways. Fairly simple? Is it coming back? Yeah? Yeah? All right. So let's see if you can do this next one by yourself. Example number 2. -4 plus -5. Do that 4 ways. I'll give you a head start, and then I'll go over to confirm that you got this. Go. So copy that and simplify that by yourself. Go. All right, let's see where we're at. We started with 4 negatives, 1, 2, 3, 4. Then it says add 5 more negatives, 1, 2, 3, 4, 5. Do you see any 0 pairs? Nope, so this is -9. Hands if you got that. Okay. From there we go to ground 0. Here it is. We start off with -4. Then it says 5 more. Since we don't have any dirt, how deep is the hole now? -9. Number line, start from 0. We go to the left 4 steps, 1, 2, 3, 4. We land at -4. From there we go again to the left 5 more steps, 1, 2, 3, 4, 5, and we land at -9. And the last one, using the absolute value, we got -4 plus -5. Absolute value of -4 is 4. Absolute value of -5 is 5. Are they the same sign? Same symbol? Yes. So we add these. This is 9. And what is the original symbol for both? Negative, and we're done. Yes? Show me with your fingers how comfortable you are with these. 1 being the lowest, 5 being the highest. We got some 5s, some 5s, some 5s, some 5s, some 5s, 5s. All right? All right. So far so good, right? All right, now let's kick it up a notch. Let's do this now with fractions. Copy this. Just like that. Example 3 says add 4 ways, -5 sixes plus 3 sixes. Just copy it, and then I'll get us started. Okay? So I'm going to create my partitions. Here we go. Now, first of all, I hope by now you know the difference between an improper fraction, a proper fraction, and a mixed number, yes? If you notice, these are proper fractions, yes? Which means they're less than 1. So check this out. Since they're less than 1, I'm going to make a circle so I can make a graph for each one of these. And I'm going to divide it into how many sections? 6. So watch. An easy way of doing this, you do an X and then a line down. An X and then a line down. Okay? So, Sebastian, focus. So this one, how many sections do I have that are negative? So I just label them 1, 2, 3, 4, 5. This one, how many are positives? 1, 2, 3. Can you match any 0 pairs? Yeah, right? So therefore, we cross this one out with this one out with this one out with this one, and what do you have left over? -2, and since they were in sixes, -2 sixes, can we simplify that? -1/3. Okay, let's go to ground 0. Ground 0. For ground 0, I'm only going to use the numerator since I see that we have a common denominator already. Does everybody see how we have a common denominator? So check this out. So that we can focus on the numerators, I want you to draw a heart like this. Aww. -5 plus 3. So we start with what? -5. +3 is up here. So question. Will this fit in here? The whole thing will fit, right? But will it fill the hole? No, so I'm going to make the hole up to right there. So I should have how much of a hole left over? -2. And since there was the common denominator of 6, can we simplify that? -1/3. Yes, kind of, sort of? Number line. Check this out. First, 0. Whenever you get to fractions, you need to divide it into sixes And we know that this is not more than 1, this is not more than -1. So this is -1 here, and this is +1 right here. And let's divide this into 6 sections, so I need 5 tallies. 1, 2, 3, 4, 5. And on this side, I need 5 also. 1, 2, 3, 4, 5. Now we can begin. Here we go. This one says to go to the left, how many 6s? 5 6s. So I go 1, 2, 3, 4, 5. So I'm at -5 6s. This one says to go to the right, how many 6s? 3 from where I'm at. So I'm going to go 1, 2, 3. So where is this spot at from 0? 1. How many 6s? -2 6s. Can we simplify that? Yes. -1/3. Make sense? Yeah? Yes, Mr. Q. All right, good. And the last one, -5 6s plus 3 6s. I'm going to focus on the numerators only. Absolute value of -5, 5. Absolute value of 3 is 3. Are they the same symbol? Subtract, that's 2. Which is the greatest absolute value? 5, it's a negative, and they're all 6s, so this is -1/3. Yes? And the last example. Copy this one, example number 5. I know, I understand. Last example. 5 minus -4. All right, so pens down, eyes up here. For this kind of problem, notice that this is a subtraction, yes? We're going to use the additive inverse property. However, the rule that they probably showed you before was this. Look up. Add the opposite of the second number to the first. Let me show you another one. -2 minus 3. As soon as you see a subtraction, you're going to add the opposite of the second number. What is the opposite? To the first. Let me show you one more. As soon as you see the subtraction, you're going to add the opposite of the second number to the first. So what can we conclude? What stays the same? The first number, and we change the second one to addition, right? All right, so make sure you work on your home plate for tonight. Like I said, I'll upload this at the end of the day. Have a good one, guys. Do your home plate. See you guys tomorrow. Bye.